This is a more advanced topic in graphing rationals, so I'm going to move through this video a little faster than normal, and if you're having trouble with it, I suggest you move back to some of the more introductory videos. So I have here two rational functions. These are separate problems, left and right, and we're going to solve each of them at the same time, so you can see exactly how the x-intercepts, the y-intercepts, the horizontal asymptotes are all playing into the creation of these functions based on the graphs. So first thing I'm going to do is look at x-intercepts. In the graph on the left, there's only one of them, right? It's this x-intercept right there. Because it's at -1, the factor responsible for that x-intercept will be x plus 1. I'm going to move this ink a little thicker here. All right, so that's x plus 1. And because it's crossing the x-intercept, we have an exponent of 1. Okay, we don't have even multiplicity. We have odd multiplicity because it's crossing. Okay, that's all the x-intercepts on the left. On the right, I've got an x-intercept in several places. Okay, there's one, and there's one over there. So those factors are going to be x plus 1 squared, because it's bouncing, and the one over here is going to be x minus 4. Okay, so there's your x-intercepts. Let's move on. There's a hole in each of these functions. You can see that located right here. That hole is going to be responsible for the factor x minus 2. And because it's a hole, you have that factor on top and bottom, x minus 2, top and bottom. And likewise over here, here's a hole in this function, and that's going to be located at x plus 4 on top and on bottom. Okay, next, we've got some vertical asymptotes in each of these figures. So I'll do those in purple. And these are the vertical lines going up and down over here. So you can see that one of them is at x plus 4. And that is an odd asymptote, meaning we see the function going on opposite sides in different ways on each side of the asymptote, up and down. So that gets an exponent of 1. Right? Whereas this one over here, if you look at this vertical asymptote on the right, so I have to put it on this side of the hole, x minus 1, right? That is an even asymptote because the function is going in the same direction on both sides, and that creates a squared situation on that factor. Now over here on the right graph, again, I have two vertical asymptotes. Here's one, here's the other. One of them is odd. That's the one at x plus 3, so that gets a 1 in the exponent. And one of them is even, the one that has a factor of x minus 2. So that's going to be x minus 2 squared. Now, that's all the major features in terms of x-intercepts, y-intercepts, and holes. I'm sorry, x-intercepts, holes, and vertical asymptotes. There is one major component left, which is the horizontal asymptote. Now, on this one, you see the horizontal asymptote is at y equals 3. So that makes this extremely easy. We know our ratio of coefficients is just going to be 3 over 1. Now on the right, on the left, it's not so easy because the horizontal asymptote is at y equals 0. So what we have to do in this case is plug in f of 0 and solve the equation. We're going to have 1 times -2 divided by 4 times -2 times -1 squared. Okay, the -2's cross out. -1 squared is just positive 1. So what we get is 1/4, times something, which I'm just going to call b. So 1/4 times a multiplier of b. b is not a variable, it's just a number. But that has to be equal to -1. So a little algebra tells me that b, therefore, must be -4. So I put a multiplier of -4 in front of this function. The whole point of that was so that I get the proper y-intercept. And these are your answers. These are the completed forms of the functions. You can see the non-zero horizontal asymptote is a little easier to talk about than the zero horizontal asymptote. But all the zero horizontal asymptote took on the left was one extra step of finding the y-intercept. The other major important theme in these problems is the concept of even versus odd multiplicity on the vertical asymptotes and on the x-intercepts.